Welcome back to Kafka Internal's Crashcasts. I'm your host, Sheila, and today we're diving deep into the world of Kafka's coordination mechanisms. We're currently in Level 3, Jedi Master, exploring the internal architecture and advanced topics of Kafka. In this episode, we'll be focusing on leader election and metadata management in Kafka, a crucial part of how Kafka maintains its distributed nature. Victor, are you ready to unravel this complex topic for our listeners?
Absolutely, Sheila. I'm excited to explore this fundamental aspect of Kafka's architecture with you and our listeners. It's a fascinating topic that really showcases the brilliance behind Kafka's design.
Great. Before we dive in, let's start with a quiz question for our listeners. Here's a brain teaser. In a Kafka cluster with 5 brokers, what's the maximum number of partition leaders a single broker can have if there are 20 partitions in total? Think about it, and we'll reveal the answer at the end of the episode.
Oh, that's an intriguing question, Sheila. It really makes you think about how Kafka distributes leadership across the cluster. I'm sure our listeners will have fun pondering this one. Without giving away the answer, I'd say it touches on some key concepts we'll be discussing today, like load balancing and fault tolerance in Kafka.
Exactly, Victor. Now, before we get into the nitty-gritty of leader election and metadata management, could you briefly explain what we mean by these terms in the context of Kafka?
Certainly, Sheila. In Kafka, leader election is like choosing a team captain for each group of data. This captain or leader is responsible for managing all the reading and writing for that group. Metadata management, on the other hand, is like keeping a detailed diary of everything happening in the Kafka neighborhood. Which houses or brokers are occupied, what kind of data or topics each house handles, and who's the captain for each group.
That's a great starting point, Victor. Now let's dive deeper into leader election. How does Kafka actually choose a leader for a partition?
Great question, Sheila. The leader election process in Kafka is facilitated by a helper called ZooKeeper. Think of ZooKeeper as the town hall, keeping track of all the important information and helping coordinate activities. When a Kafka neighborhood starts up, one of the houses is chosen as the mayor, or what we call the controller. This controller house is in charge of managing the election process for all the data groups in the neighborhood.
Interesting. So it's like having a central authority overseeing the elections. Can you elaborate on how the controller manages this process?
Certainly. The controller uses ZooKeeper, our town hall, to keep tabs on all the data groups and their leaders. When a group needs a new leader, either because it's a new group or because the current leader has, let's say, gone on vacation, the controller steps in. It looks at the list of houses that are up to date with that group's information and picks one to be the new leader. This decision is then posted at the town hall, and all the houses in the neighborhood are notified of the change.
That makes sense. It's almost like a democratic process, but with the controller acting as the election commission. Now, you mentioned metadata management earlier. How does Kafka handle that?
Great analogy, Sheila. As for metadata management, Kafka relies heavily on ZooKeeper for this. ZooKeeper, our trusty town hall, keeps track of all sorts of important information about the Kafka neighborhood. This includes details about the houses, the types of data they handle, the different data groups, and who's leading each group. Whenever there's a change in the neighborhood, like a new house joining or a group getting a new leader, this information is updated at the town hall. The controller and other houses in the neighborhood keep an eye on these updates and make notes for themselves.
That's fascinating, Victor. It sounds like ZooKeeper plays a crucial role in keeping everything synchronized. But I'm curious, what happens if a broker fails? How does the system recover?
Excellent question, Sheila. Broker failures are indeed a critical scenario that Kafka is designed to handle gracefully. When a broker fails, it's like a house suddenly going dark. The controller, which is constantly checking on all the houses, notices that one has stopped responding. It then springs into action to manage the situation.
That's impressive, Victor. It seems Kafka has really thought through these failure scenarios. How does this compare to other distributed systems?
Great point, Sheila. Kafka's approach is similar in some ways to other neighborhood management systems, like Apache ZooKeeper itself or etcd, which is used in Kubernetes. They all use some form of agreement process to keep everyone on the same page. However, Kafka's design is unique in how it separates the jobs of neighborhood management from data storage and processing.
That's a helpful comparison, Victor. Now, as we're nearing the end of our episode, could you share any best practices or common pitfalls to avoid when it comes to leader election and metadata management in Kafka?
Absolutely, Sheila. Here are a few key points to remember. First, always have multiple ZooKeeper nodes in a production environment. Don't put all your eggs in one basket. Second, keep a close eye on ZooKeeper, as any issues there can affect the whole Kafka system. Third, be careful about creating too many topics or partitions, as this can overwork ZooKeeper. Fourth, when possible, use smart ways to assign partitions to improve fault tolerance. And finally, regularly check for any data groups that aren't keeping up and fix them to maintain good backup capabilities.
Those are excellent points, Victor. Thank you for sharing those insights. Now let's reveal the answer to our quiz question. In a Kafka cluster with 5 brokers and 20 partitions, what's the maximum number of partition leaders a single broker can have?
Great question, Sheila. The answer is 20. In an extreme scenario, a single broker could potentially be the leader for all partitions. However, this would be highly unusual and undesirable in practice. Kafka typically tries to distribute leadership evenly across brokers for better load balancing and fault tolerance. In a well-balanced cluster, we'd expect each broker to lead about 4 partitions.
Excellent explanation, Victor. To summarize today's episode, we've learned that leader election in Kafka is managed by a controller broker, which uses ZooKeeper to coordinate the process. Metadata about the cluster is stored in ZooKeeper, and Kafka has robust mechanisms for handling broker failures. While similar in some ways to other distributed systems, Kafka's approach to coordination is unique and well-suited to its use case.
That's a great summary, Sheila. It's been a pleasure diving into these complex topics and breaking them down for our listeners.
Indeed, Victor. In our next episode, we'll be discussing the migration to K-Raft, Kafka's new consensus mechanism that aims to remove the dependency on ZooKeeper. Don't forget to subscribe to our podcast and leave us a rating if you're enjoying the series. Until next time, keep streaming.